Welcome to the Holistic Psychiatry Podcast. I'm Courtney Brown Snyder, a physician and holistic adult and child psychiatrist. In this episode, I'll be talking about Alzheimer's. This will be part one of a two-part series. And the reason I want to talk about Alzheimer's, it's obviously quite prevalent and will be becoming increasingly prevalent, but I don't think people fully appreciate how much control we do seem to have as far as our vulnerability and our progression into Alzheimer's. This is a topic that's important to me personally. I do have a number of vulnerabilities, and I am 56, which means I could already have some brain changes that could evolve over the next 20 years, leading to symptoms of dementia. In this part, I'll be talking about the incidence, what Alzheimer's actually is, the course and the symptoms, as well as the ways it can be diagnosed using biomarkers even prior to the onset of symptoms. So while there's Alzheimer's disease, which means a disease progression, that's different than Alzheimer's dementia, which is when someone has become symptomatic and their daily functioning has become impaired. I'll also talk about mild cognitive impairment, and I'll talk about risk factors, and then most of the time I'll be talking about what appear to be the causes of Alzheimer's and some of the evidence for that. In the next episode, I'll talk about how some of these causes interact or appear to interact and intersect with one another, and what current treatments are from a mainstream model, but also from a holistic, integrative, and functional medicine model. Alzheimer's is the most common form of dementia, and it accounts for 60 to 70%. So other types include Lewy body disease, vascular dementia, and frontal temporal lobe dementia. Alzheimer's is present in 10.9% of the American population. 5% of people aged 65 to 74 have Alzheimer's, 13.1% of people 75 to 84, and 33.3% of people age 85 or older. Older Black Americans are twice as likely to have Alzheimer's, and older Hispanics are 1.5 times as likely. Almost 2/3 of Americans with Alzheimer's are women. So what is Alzheimer's? What is known is that it's a neurodegenerative condition, meaning there is death of nerve cells and over time, loss of brain tissue. The first areas impacted, including the hippocampus, are responsible for memory, language, and thinking. There are two hallmarks. One is the accumulation of a protein beta amyloid outside of the nerve cells. The other are twisted strands of a protein tau that are inside neurons. There's also evidence of inflammation in the brain and atrophy or loss of brain volume. I'll argue that the amyloid and tangles, as they're called, are likely the result rather than the cause of the problem. Regarding neurotransmitters, there is loss of brain cells that produce acetylcholine, and there appears to be interference with glutamate metabolism and function. The course of Alzheimer's, the brain changes are thought to begin 20 years or more before symptoms. Symptoms progress along with the neuronal damage. So in the early stages, meaning the early stages of when the symptoms are presenting, there's difficulty remembering recent conversations, names, or events. There could be apathy and depression. In the middle stage, there can be communication problems, confusion, poor judgment, and behavioral change. In the later stages, there can be difficulty walking, speaking, and swallowing. And while someone can die from Alzheimer's, death is often from other conditions. On average, people live 4 to 8 years after the diagnosis, though some can live as long as 20 years after the diagnosis. And this is influenced by how far the disease has progressed by the time someone gets diagnosed, and whether the individual has other health conditions that they could die from instead. We now have the ability to diagnose using biomarkers before the full onset of the illness. So there are abnormal levels of beta amyloid and tau in cerebral spinal fluid, and so this can be measured. Also on PET scans, there can be imaging that shows where beta amyloid and tau have accumulated in the brain. More recently, we have blood tests that can measure levels of beta amyloid protein and tau protein, but these tests aren't widely available. Insurance coverage for these can be limited. So again, someone may not have any symptoms of Alzheimer's and already be able to be diagnosed with the disease. And again, not necessarily dementia. This is where you'll hear of someone having the diagnosis of mild cognitive impairment due to Alzheimer's. And this is where they'll have biomarker evidence of Alzheimer's brain changes and new but subtle symptoms such as problems with memory, language, and thinking. These cognitive problems may be noticeable to them and their family or close friends, but not to others. And they may not necessarily interfere with the person's ability to function on a daily basis. And once that is the case, then someone would meet criteria for dementia. But everyone who develops Alzheimer's dementia first has mild cognitive impairment, though again, it may not be recognized or diagnosed because it can be fairly subtle. Some individuals with mild cognitive impairment, or MCI, don't have additional cognitive decline, and they may even revert to normal cognition. Studies have shown, and this has been like a meta-analysis where they pulled together a lot of studies, that there's a reversion rate, so someone having mild cognitive decline, and then that reverting and them being back into a state in which they don't, and that's about 26%. So that's important because it shows us that there's something flexible here, something that can be reverted. That's why I want to talk about this, because from a mainstream model, while there are discussions about this, it's very different from a functional and integrative holistic model where we really go after what we see as the root causes with the expectation and intention of halting or reverting this disease process. So identifying which individuals have MCI and are more likely to develop dementia is a big area of research right now. And again, if we can identify who those individuals are early, more can be done to halt or even revert the condition. So let's talk about the risk factors. Age, certainly we become more vulnerable as we get older. There's increased risk of Alzheimer's from having had a moderate or severe traumatic brain injury. And this likely relates to what is called microglial activation. That's when there's been an insult to the brain, and it activates these inflammatory cells in the brain such that when there's another insult that comes along, and that could be a toxin, it could be another source of head trauma, and those microglial cells are much more quick to react, and the response is more dramatic. Again, it would make sense if someone's had a head injury that they would be more vulnerable to this type of brain inflammation, and brain inflammation does appear to be at play. Midlife obesity is a risk factor. I'll talk about the role of insulin resistance in Alzheimer's, so that would make sense for that reason. Hypertension is a risk factor. High cholesterol. I'll be discussing ApoE4, which is a gene that raises one's risk, certainly for Alzheimer's. And it also plays a role in high cholesterol. If someone doesn't get much physical activity, that's a risk. I did a recent newsletter on the role of physical activity in brain health that goes into the many mechanisms that protect our brain when we exercise. Poor nutrition. This can relate to the low level of antioxidants that we're getting, but it could also be the high sugar and carb intake that can affect that insulin resistance, which I'll talk about, as well as feeding problematic microbes such as yeast and mold. There is evidence of these microbes actually being present in the brains of those with Alzheimer's. Inadequate sleep or poor sleep quality. An important function of sleep is actually the removal of these toxic beta amyloid and other substances from the brain. Obstructive sleep apnea may increase that risk further. There's evidence of certain air pollutants and toxic metals, and I would add to that mold toxins and toxins from Candida. So from the Alzheimer's Association, they would say, quote, "There is no proven way to prevent Alzheimer's disease, and there is currently no cure," unquote. From what is being learned with quite a bit of research to support it is that there are known contributing factors, and we do know how to impact some of those contributing factors. So what do we know? We know that the plaques and tangles are present, and some researchers would suggest that instead of those being the problem, they are actually secondary to metabolic issues that are causing the plaques and tangles. And the metabolic issues are also causing neurotransmitter problems, including loss of brain cells that produce acetylcholine and interference with glutamate metabolism and function. The 5 areas that I'm going to mention are going to be ApoE, neuroinflammation, insulin resistance, oxidative stress, and I'm also including microbial presence, because even though that's not talked about, there actually is some really interesting research there. So to start with ApoE, though there are 31 genes that appear to affect our biological processes that are at play in Alzheimer's disease, ApoE4 has the strongest impact on the risk of this late onset Alzheimer's dementia. There is an earlier onset that has different genetic vulnerabilities, and the earlier onset Alzheimer's is much less common. So I'm focusing more on this late onset Alzheimer's. So the ApoE gene provides the blueprint for a protein that transports cholesterol in the bloodstream. So we inherit an ApoE gene from each parent, and that could be E2, E3, or E4. And so we have the potential for 6 combinations of these genes. So having the E4 of the ApoE gene increases one's risk of developing Alzheimer's dementia compared to the E3 and E2. But having E4 does not guarantee that an individual will develop Alzheimer's dementia. Having E2 appears to actually lower the risk, and E3 appears to be neutral. Aside from being the blueprint for a protein that transports cholesterol in the blood, ApoE appears to interfere with our brain's ability to use insulin, resulting in cells starving because of not getting glucose. So insulin helps glucose go into the cells, including the nerve cells. If we have insulin resistance in the brain, the cells can be starving and dying. And this is part of why Alzheimer's is referred to by many researchers as type 3 diabetes. And I'll talk about insulin resistance in a moment. ApoE4 carriers have altered brain insulin signaling and glucose metabolism. I'll share a link to a study at the University of Kentucky in Lexington, not far from here. They did a genetic manipulation called Meet the Switching Mice. They flipped their glia ApoE4 to ApoE2. And in doing so, these mice were able to clear plaques, calm microglial cells, improved memory, even when they still had an amyloidosis. The second is neuroinflammation. Beta amyloid and tau accumulation are believed to activate microglia, which are inflammatory cells again in the brain. And when they get busy doing their thing to try to clear toxic proteins and debris and dead cells, that is like an inflammatory scrubbing, essentially, of the brain, which can create cell death if done to excess and damage to brain tissue. So lowering this brain inflammation can be a target of treatment and prevention. And in fact, mast cells are even being considered as a target. So mast cells are part of the inflammatory response in the body, but they do communicate with microglial cells in the brain and activate them. Thirdly, and I think which is deserving of perhaps the most attention here, is insulin resistance. So insulin resistance occurs when cells do not respond to insulin as they should. This can happen when blood sugar levels are high over time. And this can lead to one having a greater risk of weight gain, but also developing diabetes, especially type 2 diabetes, cardiovascular disease, and cancer, but also Alzheimer's and other brain-related conditions. We can have insulin resistance in the brain. The receptors transporting insulin across the blood-brain barrier can become resistant to high insulin levels. This results in low insulin in the brain, and thus brain cells being exposed to high blood sugar without a means to use it. Without an adequate energy source, brain cells can't function properly. This lack of insulin getting into the brain is also problematic because insulin plays a role in neuroplasticity. The first area impacted is the hippocampus, which again is involved in that memory formation, learning, but also spatial awareness, mood, and emotional processing. In Alzheimer's, there's evidence that glucose metabolism starts decreasing 18 years before symptoms and 5 years before atrophy. There's a lot of research that has linked diabetes and Alzheimer's, although one doesn't have to have type 2 diabetes to have Alzheimer's. Most with Alzheimer's have either type 2 diabetes or elevated fasting blood sugar levels. There is an increased progression to dementia for those with high blood sugar. So the fourth area is oxidative stress. Of what I've talked about, certainly the insulin resistance in the brain could contribute, inflammation in the brain could contribute, but oxidative stress is when our body's antioxidant system has been overwhelmed by an excess of free radicals, and this could be from injury, from inflammation, metals, radiation, and even, I would argue, the presence of microbes. And this depletion of antioxidants by this overwhelm of free radicals can lead to cell death. And it has been found that copper, zinc, superoxide dismutase, which is a major antioxidant, and metallothioneins, which are an incredibly important antioxidant, are depleted in Alzheimer's. So metallothioneins are present at the gut-blood barrier, but also the blood-brain barrier. Metallothioneins are what secure the blood-brain barrier and keep heavy metals out, regulates copper, and is a powerful antioxidant in of itself. It needs glutathione and selenium to function properly, and in order for metallothioneins to be expressed, for these proteins to really be created, requires zinc. So I've talked about zinc recently, and it's one of those don't get me started because I love to talk about zinc, but here it is again, so important when it comes to our brain health. And in this case, in making metallothioneins, which are addressing and keeping things that are problematic out of our brain. And then lastly, I'd like to comment on their microbial presence. There is evidence, and I'll share a link if you want to take a deeper dive. There have been research studies that show evidence of candida and mold in the brains of individuals with Alzheimer's. These different areas can be working together. It's interesting to note that these microbes, specifically candida and mold, do thrive on glucose. So we know that there's insulin resistance. There's glucose in the brain. It's not making its way into the cells. There's evidence for a microbial presence. We know there's inflammation, which could be because of microbes, because of metals, because of a history of head trauma. And we know there's oxidative stress, and that would be related to these various things I'm mentioning. And all of these things could be at play and working together. But we also know how to address oxidative stress. We know how to address inflammation. We know how to address the presence of candida and mold. And we know how to regulate our blood sugar. And at some point, we're going to know how to replace our ApoE4 with ApoE2. In the next newsletter and podcast, I'll talk about how these factors could be working together. I'll talk about mainstream treatments and integrative, functional, and holistic approaches. I hope to connect with you then. If you have any questions or comments, I always welcome further discussion. If you'd like to receive these in your mailbox each week, please consider subscribing at CourtneySnyderMD.com. And there I have information on my consultations that I offer nationally and internationally. Until next time, take care. Bye-bye.